So here we have the limit as delta x goes to 0 of delta x cubed plus 2 delta x squared divided by delta x. Now, this is a little bit different than the last couple of problems because it looks like delta x is two variables, okay? But it's really acting as one single variable. So this, what I've written down here, is equivalent to the following. We could just say this is the limit as, let's say, t goes to 0 of t cubed plus 2t squared over t. It's the same idea. Okay. So now what we'll do is I'm going to work with this guy over here, but think about this guy in the background. What we'll notice is that both the numerator and the denominator are continuous functions. So this guy up top is continuous, this guy down here is continuous, just like this guy up top here is continuous, this guy down here is continuous as well. Now, that being said, what we would like to do is we would like to say that this right here is the same as the limit as delta x goes to 0 of the following, of delta x cubed plus 2 delta x squared times the limit as delta x goes to 0 of 1 over delta x. The problem with this is that this guy right here is 1 over 0. So the limit here of the denominator as delta x goes to 0, this guy down here, this guy goes to 0. So it approaches 0. So we can't do this. Okay, so let me erase this. What we need to do is we need to find a replacement function. So we need to replace this guy up here, and how we're going to do that is we're just going to factor out a delta x out of the numerator. So we're going to say that this is the same as the limit as delta x goes to 0 of delta x times delta x squared plus 2 delta x's, that whole thing over delta x. Now these are exactly equal to one another. I haven't changed anything. Now I'm going to say that this is, the limit is going to be equal to, now the functions themselves on the inside are not equal. Okay, but watch. I'm going to say that this is equal to as delta x goes to 0 of, and what I'm going to do is I'm just going to cancel these guys out. And so this one above, you would write it just like this. You would leave that like this, and then you would say in your next step, this is equal to just delta x squared plus 2 delta x. Now, we need to reiterate this. This guy right here, I'll circle it for you, this guy is not equal to this guy. They are not the same. Okay, but they take on all the same values for every other number. So if they take on the same values for every delta x value except 0. If delta x is equal to 0, then these two guys are definitely not the same. This first guy's undefined, this second guy is 0. Okay, so they don't take on the same values when delta x is 0, but we're not concerned about delta x being 0 because we're looking at the limit. And the limit only concerns itself with delta x values that are close to 0. So the limit as delta x goes to 0 only concerns itself. Whoops, I don't know why that didn't write. Let me just drop that out. Let's do it again. Doesn't concern itself with delta x values exactly at 0, only with delta x values close to 0. That's the important part here. So we can make this substitution because these two limits are equal to each other even though the functions on the inside are not exactly the same. Now this right here is a continuous function. Okay, it's just, think about it as x squared plus 2x. Same thing, right? It's a polynomial function. So we can distribute over the sum, even though this is a function. This is it's something that's happening to these two guys here. Okay, we can go ahead and we can insert into here. So this is going to be the same as 0 squared plus 2 times 0. The reason is because delta x squared plus 2 delta x is continuous. That's the only reason that we can plug that in there, is because we have continuity. So this is going to be 0 plus 0, which is 0. So we would say at the end that the limit as delta x goes to 0, let's get rid of that, of delta x cubed plus 2 delta x squared over delta x, that is equal to 0. Okay, so this is the final answer right here. Okay. However, your answer on your exam needs to include all of these steps over here in the white. Okay. So that's how you go ahead and you work that problem.